Today we are to see about introduction to D2D communication in 5G architecture. So in today's topic, let us see about D2D 5G vehicular communication and as well as 5G public safety and disaster and D2D 5G millimeter wave communication and handover and mobility and UAV and IoT and D2D communication in 6G network. Okay, let us see these things briefly. So introduction to 5G. So your 5G is highly very high. It provides very high data rate and it is very reliable and it has very low latencies and it is very fast and uninterrupted and sharing and streaming and browsing, and its data rate is up to 1 to 10 Gbps and its latency is up to 1 microseconds round trip. Hope we are traveling in a 5G network. Hope you all know about what is the speed of this network and the 5G and IoT examples. We use these 5G networks in smart homes, smart industries, smart logistics, smart farming, and smart grids, and smart vehicle and smart health. So let us see in detail about the 5G architecture. So 5G architecture is something that base station centric to device centric. So it is an ultra dense network required in subway, malls, and offices. There is integration of 5G base station with legacy cellular networks like 5G, 3G, and 2G. So energy efficient networks, that is something that a base station with sleep mode. Cell zooming. Cell zooming is something that cell size dynamically changes depending on the traffic load. And small base stations runs by renewing the energy source like solar panels, wind turbines, and energy harvesting and UV sites. So here the CRN will be reduced over head and energy drain by simplifying the conventional cell sites and shifting all the process to the centralized cloud data center. Next, let us see the introduction to D2D communication. So let us see the few example of D2D application, that is something that video streaming, voice and data, and emergency network and M2M. So D2D released in 3GPP, that is in LTE REL12 as a component of 5G. So here D2D communication between two UE without routing through the base stations. So the capacity gain and the data rate gain and latency gain. So the main applications are the proximity based service like advertisement and V2X and interacting cloud game and public safety support. So an UAV or a drone can be a solution in emergency situation. So next is that utilizing of a directional millimeter wave for D2D communication system provides a low power and high data transmission with the manageable interference. So this diagram clearly represent the transmission using 5G architecture and what is the D2D communication. So in D2D communication, the infrastructure based or infrastructure less based applications are there. So here resource allocation and mode selection and interference calculations in license band D2D communications. So next is that the other use cases of communication system is based on IoT and D2D. So here remote healthcare, a few examples of D2D communication using IoT is remote healthcare, disaster relief and computing and proximity services. So let us see about the D2D vehicular communication. So this is an example of vehicular communication. Here it underlining the cellular network. It support vehicle to vehicle communication, that is V2X with a roadside unit to prevent accident and traffic jam. So this is the example of vehicular communication. Next, let us see about the public safety. So the public safety communication among the first responders and victims. So here D2D based cluster scheme to expand the cellular coverage for public safety communication. So the purpose of D2D cluster scheme to expand the cellular coverage, and the cluster heads are selected from the group of public safety user equipments based on different metrics such as battery power, number of discovered out of the coverage devices and mobility. So here the each cluster head provides synchronization and radio resource management information and coverage to its cluster members. Next is we'll see about D2D to enhance battery life in 5G for disaster management. Here the disaster zones may suffer from loss of communication. In this work, the user who are trapped with disaster zone have a limited or a low battery levels could seek help from the neighboring devices with high battery levels. So the selection is assisted by the disaster management server and disaster management cache. Okay, so the selection neighbor then act as a relay to extend the communication outside the disaster area. This will provide improved duration probability of the user. So the model of saving battery using D2D and SOC receiver. So next is your D2D communication. Slow down the device battery drain, prolong for using a low power transmission. So this is an example of D2D 5G post disaster relief. So the infrastructure damage or unavailable during a golden hours of the post disaster scenario. So here the network coverage is critically important than capacity during the disaster and post disaster for effective search and rescue. So in post disaster scenario, limited backup power supply to the user and user initiate D2D discovery process only when the cellular is sharply deteriorated. Next is your D2D 5G multimeter wave communication. So here D2D communication is expected as essential feature of wave 5G cellular network, and also it improves the network capacity and also built connection between two wireless devices. And here, due to the directional antenna and high propagation loss, the wave communication has relatively low multi-user interface. So next is your wave communication. So your D2D and millimeter wave are complementary in 5G network. So here the interference issues are unlicensed and there is no quality of service guaranteed. So in license band, the accurate interference management is required between the cellular and D2D communication. This diagram clearly shows about the directional communication in millimeter wavelengths allows a better interference management with high throughput. So next is your D2D 5G handover mobility issues. So here in this diagram it represents the handover mechanism for D2D pairs is not standardized yet. So when a D2D pair move across the cell boundaries, the control channels of the two QEs, that is user equipments, may connect to different base station, which may result in latency. So next is your D2D 5G handover. So here ultra low latency, that is the communication and enhancement mobile broadband and massive machine type communication. So here the mode selection process is performed to this select the best out of D2D mode and or a direct mode. Okay. Next is your 5G UAV. So UAV is something that unmanned aerial vehicles are flying base stations to provide emergency coverage for user equipments due to mobility and flexibility. So here the fixed wiring type that is good for power limited applications. So the time interference between ground users is 3D UAV. Network is difficult to model. Okay. Next let us see about UAV elaborately. So UAV for reliable communication during a grand temporary social events and military applications, and it is also used in mobile cloud computing system for providing application of offload opportunities. So these are the examples of where UAE has been used. Next let us see how D2D is used in 5G IoT. So here in first step, the IoT devices satisfies the QoS constraints are selected the matched with appropriate use candidates, and that is the cellular user equipments. And next the link is reliable for these link are computed, weak links are discarded. Finally the disconnected to IoT devices are rerouted or IoT gateway. So if you have any clarification related to this topic, please free to contact me. Thank you.